Hey there, cosmic explorers, and welcome back. Today we're going to tackle some of those huge, mind-bending questions about our universe. The kind of questions that really make you stop and wonder, is everything really what it seems to be? So you might want to buckle up, because this is going to be one heck of a ride.
All right, let's just jump right into the deep end with this one, shall we? This question right here. It challenges everything we think we know about our place in the universe. And it's more than just a cool thought experiment, you know? It's like a key that could unlock our understanding of the very limits of physics.
So let's really dig into this idea. What if our entire universe, with all its stars and galaxies, isn't the whole shebang? What if it's just a tiny little piece of something so much bigger, it's almost impossible to imagine?
Okay, so this idea has a name. It's called Schwarzschild cosmology. And the theory goes something like this. When a massive star in let's call it a parent universe, collapses, it doesn't just create a black hole. It might actually give birth to a whole new universe inside it. And yeah, you guessed it, that could be our universe. Now, this is super speculative for sure, but the fascinating part is that the math doesn't say it's impossible.
And the implications here, they're just staggering. We're talking about a black hole creating a baby universe, and that new universe would be causally disconnected. That's a fancy way of saying we could never, ever see or talk to our parent universe. It's totally cut off. And think about it. If one black hole can do that, maybe every black hole does, creating this endless waterfall of new universes, a true multiverse.
Okay, let's bring it back down to Earth for a second. We have to be super clear here. This is an idea from the absolute fringe of theoretical physics. Right now, there's just no way for us to test it or prove it. It's a really cool what-if scenario, one that totally stretches our imagination, but it's not mainstream science yet.
So we've just questioned where our universe might be. Now let's go a step further. Let's question what it is. And this next idea, well, it might be even more unsettling. We're talking about the simulation hypothesis.
The basic idea here is pretty wild. It suggests that our reality isn't actually real, not in the fundamental sense. It's more like a super advanced computer program. Everything you see, everything you feel, your memories, it could all just be lines of code running on some massive cosmic hard drive somewhere.
Yeah, and you can see why this one is, psychologically unsettling. It just messes with your head, right? It cuts right to the core of what it means to be real. If this is all a simulation, then what about free will? Are our choices actually our own, or are we just characters in a game following a pre-written script?
And this is where the big debate really kicks in. So the argument for it is, if a civilization gets advanced enough, it seems totally plausible they could create a simulation this convincing. But then you get the counter-argument, which is a really good one. If a civilization is that powerful, with enough energy to create a whole simulated universe, couldn't they just create a real one? Why would they bother faking it? What would be the point?
So that's pretty much where we are with it. It's a fantastic philosophical puzzle, a great thought experiment, but there's zero physical evidence to support it or to deny it. It's really a question that belongs as much to philosophers as it does to physicists.
All right, let's switch gears a bit. We've been talking about these big, purely theoretical ideas. Now let's look at stuff we can actually see. Because, the universe sometimes throws us these strange curveballs, these little puzzles and anomalies that just don't quite fit with what we expect. So the question is, are these just mistakes in our math, or could they be little clues pointing to something deeper? First on our list is a star that's got a pretty wild nickname, the Methuselah star. And it's a real cosmic head-scratcher because this thing seems to be, ancient. Like impossibly ancient.
Get this. Its estimated age is about 14.46 billion years, give or take. Okay? Just lock that number in your brain for a second.
Because here's the kicker. Our best, most accurate measurement for the age of the entire universe is around 13.8 billion years. So, how can a star be older than the universe it's in? It just doesn't make sense. It's a textbook paradox. Now, before we get too carried away, this probably isn't going to rewrite all the physics books. Most scientists think the answer is in those little plus or minus numbers, the uncertainties in how we calculate a star's age. It's a great puzzle, but what it really shows us is just how incredibly hard it is to get these cosmic measurements exactly right. All right, on to the next puzzle. If you look at the afterglow from the Big Bang, what we call the cosmic microwave background, it's unbelievably uniform in temperature. Almost perfect. Almost. except for this one huge patch that's way colder than it should be. So, what is it? The really wild speculation is that it's a kind of cosmic bruise left over from when our universe bumped into another one.
So you've kind of got two camps here. There's the leading scientific explanation, which says it's caused by something called the Eridanus supervoid, basically a gigantic empty region of space that makes light look colder as it passes through. And then you have the more exotic idea, the colliding universe theory, which is super cool to think about, but as of now, there's really no evidence to back it up.
Oh, and hey, remember Tabby's star? That was the one that was dimming in this really weird, random way. For a while, everyone got super excited, thinking maybe it was a giant alien megastructure, a Dyson sphere or something. But as science tends to do, a much more down-to-earth explanation came along. The current best guess? A big, uneven cloud of dust.
Okay, for our last stop on this journey, we're going to the ultimate question, the biggest one there is. We've asked where we are, we've asked what we are. Now let's ask, how did any of this even get started?
All of our physics today points back to a single moment of creation, the Big Bang's singularity. And it's important to get this right. It wasn't an explosion in space. It was the point from which space and even time itself burst into being.
And right there, that's where we hit a wall. A hard wall. Our two greatest theories of the universe, general relativity and quantum mechanics, they just break. They stop making sense. They can't describe what was happening at the singularity itself. It is, for now, the absolute limit of our knowledge.
And that leaves us with the most profound questions you can imagine, like what was there before the Big Bang? That question might not even be logical, because before is a measure of time, and time might have started right then. We have no idea what caused this singularity to pop into existence, or what gave it the push to start expanding. This is the bleeding edge of physics. So, ironically, we're ending our journey right back at the beginning. What was it? A random flicker in the quantum foam? Just one beat in an endless cycle of cosmic birth and death? Or something we can't even conceive of? That one question, what lit the fuse? That remains the ultimate mystery. And it's what keeps us looking up at the stars and always asking, why? Thanks for coming along on this cosmic trip.